No idea. I've got to find out how to turn that off again. Okay, so let's take a look at number 9 through 11. 9 should actually be a pretty easy question, pretty straightforward. We're just going to look at what things are. So again, all we really have to do is look at the squared terms in these particular problems. So I'm just going to highlight those so that we can discuss them as we play through. But here, notice that x squared and y squared are both positive, and they're definitely different, which makes this a nice little ellipse. Now, moving into b, you'll notice if we were to bring this across, we would have a 9x squared minus a y squared again. As long as one of them is positive and one is negative, we're looking at most definitely a hyperbola. Now, here we have a little interesting thing, because you notice if we brought those across, the x squareds would cancel, which makes it a parabola. Now, again, obviously, I was trying to trick you by making you think it would be an ellipse by simply looking and seeing these different numbers. But again, we sometimes need to go ahead and clean it up. Similarly, on this one, if you move this across, you would get 8y squared and an 8x squared. And since those are the same, we're actually going to use the most accurate term possible, which is a circle. I know you could call it an ellipse because that's technically a very special ellipse, but that's not an accepted answer in any circle that I've ever known. We definitely would want to call that a circle because it's the most specific one we can. Now, this one's kind of weird. As soon as you know that it's got 2 foci and 2 vertices, it's either going to be the hyperbola or it's going to be the ellipse. We just need to figure out which one is which. And so let's see what happens. Now, it says that the foci are at -1, 9, and -1, -1. So I know it's something that's lined up and down, either an ellipse or a hyperbola. And the vertices are actually inside at -1, 2 and -1, 6. So they're right in here. So the interesting thing is if it is an ellipse, the vertices are outside and the foci are inside. But in this case, since the vertices are inside and the foci are outside, then that makes this most distinctly a hyperbola, which is pretty cool. So that's number 9. So let's go ahead and check out number 10. Now, number 10 isn't just asking you to name it, it's actually finding it. So we definitely know we have a parabola, and we have a given directrix and a focus. Okay, well, that's awesome. So we have a horizontal line as my directrix. We now have 2, 7, which is actually above it. 2, 7 is going to be my focus. So I do know that the parabola has to be opening up. So the first thing that I know is it's going to be one of those problems that is going to be an x squared, and there's going to be a 4p and I guess I'll just kind of write it this way, like that. Now, what I do need to figure out is what is right in the middle of these. And one thing that is true is the x value for the vertex is going to have to be 2 right here. But the y value has to be right in the middle of 7 and -1/2. Now, to find the midpoint of things, we always just add them together. So I'm going to take 7 and -1/2, and I'm going to add those together, which of course gives me 6.5. Let's divide that by 2, which is 3.25 or 13/4. So that gives me my vertex, x minus 2, y minus 13/4. There's my vertex. And what I also need to know is what is the distance from this vertex to the focus. And from 13/4 up to 28/4 is 15/4. So p is 15/4. Now keep in mind, this is 4p, which makes that number 15. All right. We'll just go up 11 and 12. Now, 11 asks for an ellipse with these 2 vertices. Now, keep in mind, if I have those 2 vertices, then the center has to be right in the middle of them. I also notice that it lines up, these are vertical to each other, right? 4,3 and 4,9, they're up and down. So I know that no matter how I set this up, the y value has to be the driver in this particular story. And so it went up and down 3 units, which makes this a 9. And then the only thing I have left to do is figure out what this is. But remember, in an ellipse, it's a squared minus b squared equals c squared. I already know a squared is 9. I know that if this is the focus from here to here, c is 2, because c is always the distance from the center to the focus. So if c is 2, c squared would be 4, which means b squared has to be 5. And I'm good to go with that one. Keeping on moving on. One more on this one, the hyperbola with 3, 7, and 7, 7. So foci of 3, 7, and 7, 7. Foci definitely lining up this way, so I know that x is going to be first. It puts my center at 5, 7. It's got a vertex at 6, 7. So again, this is kind of cool. So 5, 7 is my center and 6, 7 is my vertex. I literally only went over exactly 1 unit. So a is 1, therefore a squared is also 1. I also know that from here to here is 2 units. So I know c is 2. And in a hyperbola, a squared plus b squared is c squared. So a squared plus b squared is c squared, making b squared 3. And I think that will do for problems up through number 12. All right, see ya.